This video will be a short introduction in SHINING3D Inspect software, and it will show you how the software is to be operated. Now, in the beginning, we have to import our reference and measure data. That is by clicking on the button, and you can select step files or STL files for reference. In here, I just will import a step file of a plastic injection molded part. The scan will be imported as an STL, and as usual, these scans are not aligned. So the very first step is to align the measured part onto our CAD part. First step will be a pre-alignment done with best fit alignment. In here you can leave the settings as they are. We have a sampling ratio of 3, maximum 50 iterations, and a conversions value of very small. Here you have to preview the alignment, and after that you can confirm that the pre-alignment has been done correctly and the pre-alignment is done. For the actual alignment, I'm going to do an datum alignment on here, and therefore we have to generate features and assign datums to these features. And here we can just create the features by using CAD auto create. Make sure to check extract measured feature in the functionality, so that saves a lot of work later on. And then we can just mark the surfaces for our features in here and simply confirm them. After that, we need to assign datums, and that is done with the right mouse button on our planes. And since these planes will stay in the reference frame of our very first pre-alignment, I would set datums or datum names that are at the very end of it. So for these ones I would use X, Y and Z. Right mouse click, scroll down, right mouse click, set as datum, so we can use them without interfering the datums that are assigned on a possible inspection plan. So after that is done, we actually can keep our screen a little bit more tidy, and that is by simply selecting our planes. You can press Ctrl to add planes to the selection, then right mouse click, and you can use group to put these planes in a group. And you can also rename this group by double clicking and give that group a special name. For example, groups for alignment or planes for alignment. So when that is done, you can also compress this group so you have a tighter and ordered left side of your screen. You can also hide the complete group, which also makes living much more easy. So next step then would be the final alignment. So we go back to the alignments, go to datum alignment and select our datums that have been generated before. Can set it to preview again and confirm our values in here. As you can see, the first datum is perfectly matched and the other two datums are increasingly in higher deviations, which is as it should be, because the real part never is rectangular. There's always a little deviation, and that is shown in here perfectly. So this alignment, when it's done, is our actual alignment. It's the active alignment, and if you want to hide the annotations for that alignment, simply click on the name of the datum alignment, go over to the right side, and in here you have the label display visibility, and you can hide or show as it is needed during the workflow. So let's hide them at the moment. Additionally, we have an alignment matrix, and this alignment matrix is quite useful because it shows the movement from the imported position to the actual alignment. So this can be used in an automation, and with that you can save a little bit time that is needed for the correct alignment, because you can directly move it using a matrix operation. Okay, since that is already done, we can next hide our measured data, so we have a cleaner screen again, and start by inspecting our part. And the very first thing we could do is to do some comparisons. In here, let's start with a 3D comparison. You can set it as reference data, measured data, which is preset already if you only have two files in here, one reference and one measured. You can also set the alignment that has to be used for our inspection. Currently is the active alignment set in here, but you could also use other alignments if needed. Let's keep it the datum alignment. Then you can enter the tolerance frame. I will keep it at 200 microns in here, and you can also set a maximum and minimum value for evaluation. And in here I will set it to 10 times tolerance. We also have two ribbon templates in here that might be changed in future, but currently there are only two. One is asymmetric, showing dark blue at the minus value and dark red as the plus maximum evaluated distance, and in the middle the tolerance is shown in green. The other template would be dark red in both direction, plus and minus. Let's keep it on template number 1. You can get a preview again on your part, and you can also set some annotations on your part that show the color of the deviation. Unless it's in tolerance, then it's shown in green. So let's try to get a blue one also. Here we are. So you have plus, minus, and inside tolerance in here. These annotations are just visual information. A point information will not be applied to them. It's just visual information that on the assigned point there is a deviation of the value shown in this little annotation. This comparison can be then also added to the report. Simply mark the comparison or the evaluation you want to do. Click on Add to Report and you will get a success message. This evaluation is now part of the report. After that, you can hide it, keep your screen tidy, and go to the next comparison, which would be the local comparison. Now, local comparison is especially useful if you have other tolerances on a smaller part of your whole part to be inspected. Let's zoom in a little bit and simply select the surfaces to be inspected. Simply select them with the mouse. If there are small surfaces, that might take a while. But you will also notify later on that I can set another tolerance frame in here. So for this little part, I can set tolerances that are tighter than before. I will keep it to 1/10 of a millimeter, maximum minimum 1 millimeter, and the color bar will stay the same. Just by clicking preview, you can get a local 3D comparison, and the annotations on the part still will be only visual information without any real inspection point created on the part. And there we go. Confirm, and same procedure as last year. We can just mark our to be inspected feature, go to report, add to report, we get another success story, and there we go. Let's hide it. Next thing is, in comparison, a 2D comparison. And for that we have to generate a cross-section. In cross-section there's not so much functionality, there's just one button. Go there and generate a reference cross-section. You can't click on both of them, so better start with reference cross-section. You get again your nominal file, you get your measured file automatically, or later on automatically. Right now it's just on the nominal file. Methods are several available. So in here I could use from planes or along specified directions. If you have a plane, you can start with the planes you already generated. So let's start with reference plane number 1, which is also our X-plane, and give it an offset. So in here you can set the offset. Negative values are also allowed, and you can see in here the offsetted cutting plane. So the position of the cut is shown here already. And after that you just have to confirm. This generates a cross-section through our nominal part. When that is done, it's also visible in here. For the cross-section of our measured part, simply right mouse click this cross-section and extract the measured cross-section from the scan you imported before. So simply confirm, and there we go. Now we can also do an inspection on this cross-section by 2D comparison, in which we have to define which cross-section we want to inspect. We can set the parameters in here. Again, we can also select the templates, and there's also a whisker multiplier, which makes our deviation more visible to the user. So let's put that on a little higher value and click on preview. In here we can see the deviation of our part, and also the whiskers in there are more dominant than the true deviations on my part. Same as before, you can set positions to find out about deviations we have on our part, and you can also change the visco display later on. So let's go back, give that a little higher display, and go on preview again, so maybe we get some nicer information. So in here you can see very clearly how the deviation is building up on our part. Might be some useful information. Let's confirm that. And because we are looking at our part in the report also, we can hide the part for the section information, and for the cross section also go to report, edit to report, and there we go. After that, hide it, and we can continue with comparison points. Now these comparison points are listed in a point group, so by defining these points we get also point information. Again, tolerance frames are added in here. There's also a maximum distance, so every point that has a higher distance than 4 millimeters will not be evaluated, and the radius of our inspection point currently is 2.5. I will set that to a little smaller value, and then you can simply mark your inspection points on the part and get information of that specific point. Can then also sort out the annotations again. Let's confirm that, so we have a little bit more space on the screen. And from these surface comparison points, that can be also in a group if needed, we can again generate an entry in our report, and that is how the comparison functionality works in here. Next is feature generation in general. For dimensioning we need features, and these features have to be generated before we start dimensioning the part. We already generated some planes, but these planes are in the reference frame of the very first alignment of our best fit alignment, so we have to do it again for the datum alignment. And therefore we could start with some features. So I will skip the very first feature I did for alignment, because I want to generate a common feature from the outer and the inner plane. That is done not with automatic generation, but in here, in plane, pick on CAD model, you can pick multiple planes for a single feature. So if you do so, generate the reference feature, extract the measured feature, write a go, and you can select two planes if they are coplanar, and by clicking on confirm, a common feature will be generated. So that would be one possibility. Of course, we have the CAD auto create button. Also in here, don't forget extract measured feature. Also lock the drop down in here on the screen, and then you can generate multiple planes one after another. So let's do that. You can see that is a quite comfortable functionality, because you simply select the features on the screen, and as soon as you confirm them, these features will be generated and the measured will be extracted from the mesh. So it makes sense to keep an overview over the features you create. So we start with plane number 5 and we end with plane number 14 on the other side. Just to keep some sort of order in our tree, again, I would start with a group. So just select all these planes. There we go. And right mouse click, put them in a group, so you can handle this group more easily. Can give it also a name. So maybe let's call it planes for dimensions. There we go. After that, you can compress that group. You will find it by the name quite easily, and you can also hide these planes. Then we can start and measure or dimension our part. In there you can dimension distances, angles and diameters currently. So for distance, we're going to do plane to plane. And in there we can simply select the planes if they are visible. So planes for dimensions. We could select the planes right here. So the plane name will come up accordingly. Or if there's too much on the screen, you can also hide the planes and simply remember which plane you want to add for the measurement. You can also set the tolerances in here. They are usually plus minus the same, but you can also have asymmetric tolerances. How that is done? Very easy. You can set the top tolerance, and as soon as that one is set, you have the possibility to set the lower tolerance to another value. Here we go, and we have an asymmetric tolerance, and you can also define the distance, the direction of our measurement. So we could do a 3D distance, but we can also do Z-axis direction in here, which makes the whole thing a slightly different value. So we have our deviation set in here and can confirm that value. So for the next, I will just add several more dimensions in here. So one is in here. Then have this distance in here. That distance. The next one would be this to this, and so on. So you can very easily generate quite a bunch of dimensions in here. If you can see that you picked something wrong, not a big issue. Simply correct it and confirm later on. So there is one missing still. And after you've done all these measurements, you can sort them out on your screen, so you get a more readable outcome in here. And after that, guess what? We are going to add it to the report. There we go. So again, we have a lot of measurements, and these measurements are selected one by one again. Right mouse click, put in a group, and this group will be, for example, located in distances top view. So these distances top view can again be put in a report or to the report and hidden. That is one. Of course, we have more on our part. So if we have, for example, a cylindrical feature, let's do that. Pick on CAD model. There we go. Extract measured feature, of course. We get a diameter directly on the cylinder, but there's also a possibility, let's hide that cylinder, to add a dimension in here. So we just have to select our feature. We get a tolerance assigned to it, and we get a deviation of the measured according the reference. Let's confirm that. Also, this diameter will be added to the report. So there is the angle setting missing. We have to find an angular feature also. Therefore, I'm going to go back to the feature and generate a feature from multiple selections. So like this and this. So we have a new plane, and we can just make a new dimension, angular dimension, plane to plane in this case. Let's do plane number 5 according plane number 15. So right now you can see what happens when you're doing the wrong things. We said, obviously I clicked the wrong plane in the beginning, and what I did in here, plane number 15 has no measured feature, so I have to go there and generate measured features manually because I forgot it. Extract measured feature from our part using a datum alignment, and there we go. Now I can also measure the angle plane to plane from plane 4 to plane 15, and I get some reasonable value. So my reference value is 45 degrees, measured is 44.9, and I'm still in my tolerance. Could make that also a little bit smaller. So changes are always possible. And there we go. So plane number 15 will be hidden also, and for our angle we can also add an entry in the report. These are the measurements, but we have more in here. We also do have shape tolerances, position tolerances, and a profile tolerance that is at the current state of development not really a profile tolerance, but also only planarable, so it's applicable only for planar surfaces, which will change quite soon with a next release. So let's start with shape tolerances. Shape tolerances available in here contain flatness, straightness, circularity, and cylindricity. For here, I would just do an example for flatness. You simply have to select the according plane. I will generate the plane down here. You can set the tolerance and you can confirm, which gives you the measured value and the tolerance and of course the GD&T symbol. Let's hide that. So that would be planarity in here. You can also have cylindricity, what we can see in here. Select the cylinder, well, we only have one, set the tolerance and confirm. So shape tolerances do not require a datum, so we are actually done in here, and we could also put a group in here, rename it to GD&T 01 or whatever you like, and mark it, guess what, put it into the report. And then hide it, keep your screen tidy again. So next thing would be dimensions or tolerances using a position which require datums. And since we had to do our datum planes in the current alignment frame again, we have to set also new datums. And this time we can also set the datums that are shown on the inspection plan. So let's go back to our planes we have in here. Planes for dimensions. There we go. And add some datums in here. So this will be datum A. Then I think that should also almost be enough, but I will add another datum to this plane. Oh, sorry, it should be another plane. It should be this here. So let's go down. Just confirm that you're on the right plane. There we go. That's plane number 14. And this one should be datum C. I forgot one plane, but you can also edit at any given time. So let's just go back to features and generate this plane again. There we go. Confirm. And this plane will be then added as datum B. Right mouse click, set as datum B. So right now we have quite a bunch of datums again. Let's hide and compress all these planes. Not really needed at the moment. And then here we are. Then let's start with our position tolerances. So in here at the moment we have perpendicularity, which could be, for example, that we have for our plane 16 perpendicularity according our plane our reference A, which will be shown on the screen immediately. And another way would be that we have, for example, a parallelism of plane number 5 according our datum C. There we go. Confirm. So that would be one possibility. Another possibility would be that we are going to show the position. That could be the position of cylinder 1 according A, B, and C. Also that is a possibility to show. And here we are definitely out of the range. Okay, so also these ones can be added to our report. After grouping them, simply select the group and again put it into the report. And after that, that would be GD&T group number 2. So that is already quite a lot, but we also do have some features that are generated within a section. So you can also use this for additional evaluations. So from here, let's find out. We have the possibility, for example, to generate lines in cross-section. So if you go to cross-section, select the cross-section in here, it should be possible to generate lines. This cross-section, of course, should be visible, which it is. Let's see what we get. There was my mistake. Cross-section 1 was visible, but the general cross-section setting was not visible. That was a reason why it didn't show up. So let's go again. From cross-section, here we are. And then we can just generate lines directly in the cross-section, extract measured feature with it, and then you can generate features in there. Let's try some more. There we go. So you can also set features, two-dimensional features on a cross-section, and also use them later on, for example, if you want to have dimensions. And here we, for example, do have line to line. So from 2D line 1 to 2D line number 2, we do have also a distance that is located at this special cross-section position. Let's do that in X direction and confirm. So that is also a possibility to get even more information from the part. And finally, it comes to report generation. So after you did all your steps in here, let's just go down and also put all the lines into a single group. maybe even hide this group so only this stays visible. And after that, simply go to preview report, just click it and the report will be generated. When the report is done, you will see the results in here, and you also have the possibility to change some entries in here. So you can set your name, that's me of course, can set the location, and you can also set the part number and confirm. That will be then entered in your mask, and you will see the entire report as a printout. You can save that as comma separated file or as a PDF. So for here I will export it to a PDF that can be saved at a specific position. You can give that a name and save it in here. So this is a single inspection. By the way, the PDF shown after that is just looking like that. Again, we have all the steps in our report. So that is done. And right now that was a single workflow for a single inspection. But you can also have more by saving it under project. Not only save as project, but you can also save it as a template. So if you do that, save as template, let's save it as default template. The whole thing is going to get repeatable. So by starting a new project and create that project from a template, we could save it, but we did that before. Let's save it. You can select files. So you can select your template file and you can select your scan. So we started with scan, let's do the same with scan number 2. And after confirming, the whole workflow will be generated automatically, and you get a new scan and you get new values and new evaluation. The only thing you still have to do is to preview the report and make a PDF or print it out as you like. So we have to change the part number in here. And that's all we have to do for the second part and every coming part. So repeatability is also available and handled very nicely in this cool little program. And that's all for now. If you have questions, very welcome to send me an email or give me a call. I'll be happy to guide you through. Thanks a lot.